Okay, we have completed the most important segment of driving a school bus, and that is your pre-trip. The second most important part of driving a school bus is to make sure you can control the school bus, especially as we think about the braking system. Most school buses today have air brakes, and so in this section we're going to concentrate on air brakes and their operation and what you need to know as far as passing your knowledge exam, and also how it actually operates on a bus to give you a better understanding of what to do or what to share with your mechanic in case there are problems. So let's take a look at air brakes. And again, I apologize for any technical issues we might have, and also for the quality and age of some of the videos. Some of them are from years ago, but they'll help drive home the point by way of video and assist you in passing your tests that you have to take.
In this presentation, you'll learn about the design and operation of air brake systems. Air brakes are used on heavy vehicles such as trucks and buses because they're more powerful, durable, and safer than standard hydraulic brakes. A basic understanding of how air brake systems work can help you avoid common problems and could make a life-saving difference in an emergency. From the driver's seat, air brake controls may look familiar. A foot pedal controls the service brake, and a knob that pulls in and out controls the emergency or parking brake. In vehicles with air brakes, however, the service brake pedal actually operates a valve called the treadle valve. When the brakes are applied, the treadle valve opens and pressurized air rushes through a series of lines, relays, valves, tanks, and chambers, exerting pressure that ultimately slows the axle and wheels. The heart of the air brake system is the compressor. The compressor draws air from the atmosphere and pumps it into the system. The brake system is a closed system, meaning that air can't escape from a properly functioning brake system unless it's released deliberately. So, just like a basketball being inflated by a hand pump, the more air pumped in, the greater the pressure inside. The governor controls the amount of air the compressor pumps into the system, maintaining a safe operating range between 90 and 120 pounds per square inch, or psi, about 3 to 4 times the pressure inside an automobile tire. When pressure in the system drops below 90 psi, the governor signals the compressor to pump more air. And once pressure reaches 120 psi, the governor signals the compressor to shut down. An electronic sensor mounted on the governor triggers audible and visual alarms if air pressure in the system drops below or exceeds safe operating levels. From the compressor and governor, air moves through the main air line underneath the bus to the air dryer. The dryer pulls moisture from the air and expels it from the system. You might wonder where this moisture comes from, so let's pause for a quick science lesson. The air around us always contains a certain amount of moisture. Clouds carry lots of moisture, but even clear air holds some. Weather forecasters call this relative humidity. Generally speaking, the warmer the air, the more moisture it can hold. When outside air is drawn into the compressor and pressurized, it becomes warmer. When it leaves the compressor and moves into an area with slightly lower pressure, it cools down. When that happens, a very small amount of moisture is deposited on the walls of the brake line. This same thing happens on cool summer nights when moisture in the air is deposited as dew on the ground. But moisture can mean danger for air brakes. During cold weather, it can freeze, block the air lines, and cause brake failure. Even in mild weather, moisture can cause corrosion that can clog air lines. Now let's return to the brake system. Moisture collects at the bottom of the air dryer, where it is periodically vented from the system by a blast of air. Next, the air is routed to a large storage tank, which is divided into 3 compartments. The first compartment is called the wet tank. This tank supplements the work of the air dryer and removes any remaining moisture from the air. The middle compartment is the primary tank, which stores air for the rear brakes. The third compartment is the secondary tank. It stores air for the front brakes. Notice that the primary tank is much larger than the secondary tank. That's because the rear brakes provide about 80% of the vehicle's braking power and require much more air. Remember the treadle valve that opens when the brake pedal is depressed? When the operator depresses the brake pedal, the treadle valve releases air from the storage tanks into a directional box, which diverts air to both the front and rear brakes. Now let's follow the air line from the storage tank to the rear brake chambers, where the heavy brake work gets done. The rear brake chambers actually have two braking systems that combine to create a fail-safe system. If the air brake system fails and loses air pressure, the emergency brake sets automatically. Let's look inside the rear brake chamber. The rear section of the brake chamber houses the emergency brake, which also serves as the parking brake. The emergency brake is a powerful spring that applies more than 25,000 pounds of pressure against the inside of a heavy steel brake drum. Since the drum is securely bolted to the rear axle, this spring prevents the bus from moving. It takes an opposing force, provided by air pressure in the brake system, to move the spring back away from the drum and keep it there as long as there's enough air pressure in the brake system. If pressure is lost and the brakes fail during operation, the spring returns to its original position against the brake drum, providing emergency stopping power. While this braking action can't easily be seen, it can be heard. When the parking brake is released, the force of air rushing into the brake chamber makes a distinct sound. It makes an equally distinct sound when the brake is set and air is released from the brake chamber. Now let's take a closer look at the brake chamber to see how the S-cam, or foundation brakes, work. When the emergency brake is released and air forces the brake spring away from the brake drum, a rod connected to the brake spring assembly pushes out and away from the brake chamber. This rod connects the emergency brake to the service brake. On the road, when the operator depresses the brake pedal, increased air pressure pushes the rod away from the chamber, causing it to push against an adjustable, lever-like mechanism called a slack adjuster. While one end of the slack adjuster moves away from the brake chamber, the other, called a camshaft, turns an S-shaped cam that's attached to the end of the shaft. As this S-cam turns, it forces two very thick brake pads, or shoes, apart and against the sidewall of the brake drum. This causes friction, which slows or stops the spinning axle and wheels. The amount of friction necessary to stop a 15-ton bus generates a lot of heat. If the service brakes are overworked because they're used too frequently and too forcefully, on a long steep hill for example, they can overheat, lose effectiveness, and in some cases fail completely. Improperly adjusted slack adjusters can be another source of ineffective braking or brake failure. When slack adjuster tension is correct, the brake pads make solid contact with the brake drum. If the slack adjuster isn't set properly, the brake pads make only light or no contact with the brake drum, and braking power is lost. While most school buses today have automatic slack adjusters, models made before 1994 may require manual adjustment. It's critically important that manual slack adjusters are always properly adjusted. Since the front brakes don't contain a fail-safe function and don't deliver as much braking force as the rear brakes, the front brake chambers are significantly smaller. Air enters the front chambers only when the service brake pedal is depressed. Each time the operator releases the service brake, air that was used to slow the vehicle is released from the system, and air pressure drops slightly. A well-maintained and functioning brake system can sustain numerous brake applications before the compressor has to pump more air into the system. But needless or repeated use of the brakes can deplete air faster than the compressor can replace it, creating a potentially dangerous condition. If air pressure drops below safe levels, both a red warning light and audible alarm are triggered. As pressure continues to drop, the dashboard pressure gauge drops into the red zone. If you find yourself in this situation, stay calm. Remember that emergency braking power is just a moment away. Your first thought should be to find a route that gets you safely off the road as soon as possible. Your emergency brakes will work, but they'll also begin to overheat, especially if you're headed downhill, and they'll begin to fade or lose effectiveness. Air brake systems are designed and engineered for maximum safety. By operating them properly and staying alert for warning signs, you can help ensure that they do their job without fail.
Okay, very good. So that's the second most important thing to understand about the operation of the school bus, and that is our air brake system. Now, I understand that some of you may already have your commercial driver's license, shortened as CDL, and we certainly appreciate that. But we're going to go through some questions now to help us with more understanding of just how the air brakes operate, and also to help you receive some knowledge regarding questions you may be asked when you take your air brake knowledge test. Now, please be patient. If you have your CDL, you've already been through this, already been trained, you have your air brake endorsement, but some of us here today are just hearing this for the very first time, and it's all new for us, so we appreciate your understanding in that. Question 1. Regarding air brakes, a dual air brake system has two separate air brake systems. The first system is called the primary system, and the other is called the secondary system. True or false? Of course, that is true. There are two systems as shown in the video. Well, you have three portions of your holding tank, but two of them actually operate brakes, your primary and your secondary. And on your air gauge on the dash, it will actually have either 1 or 2, signifying primary or secondary, or a P or an S, signifying primary or secondary. When the tank pressure falls to around 100 psi, the governor allows the compressor to start pumping again. True or false? Of course, that is true. The keyword there is around. In some examinations, it'll say 90 pounds. Others will say 100. But somewhere between 90 and 100 pounds per square inch, the governor allows the compressor to start pumping air again into the supply tanks. The air tanks do not hold enough air to allow the brakes to be used several times, even if the compressor stops working. Is that true or false? It is false. The air tanks do hold more air than you need in using the brakes one time. So you can actually use the brakes several times, depending on how long they are applied, even if the air compressor fails to work. The parking brake releases and the parking brake is applied when you use the parking brake control. No, that is not a trick question. That simply is true. Parking, parking, parking all operates parking brake. All vehicles with air brakes must have a low air pressure warning signal. Well, I should hope so, because if you're thinking about your air going down, and if you didn't have a buzzer to alert you that it was getting low, bad things could happen. So yes, it is required that they all have an air pressure warning signal. Any vehicle with air brakes. When the tank pressure falls to around 65 psi, the governor allows the compressor to start pumping again. And this is kind of a duplicate of an earlier question, so you certainly should know the answer here. The answer is false. When the tank pressure falls to around 100 psi, the governor allows the compressor to start pumping again. And again, anywhere from 90 to 100. In this particular slide set, state of Pennsylvania says it's 100. I've seen it where it also would accept 90 psi. When testing the low pressure warning signal, turn the electrical power on, turn your key on, and step on and off the brake pedal to reduce the air tank pressure. This is called bleeding the brakes. The low air pressure warning signal must come on before the air pressure drops to less than how many psi in the air tank? 30, 45, 60, 90, or 100? Well, that warning buzzer better signal, a light will flash and audio will come on at least by 60 psi if your gauge drops down to 60. And that will be on a test. After the initial charging, the air compressor should start pumping at about 75 psi and stop at about 100 psi. Well, I'll kind of give you some clues and helps with the video and previous questions, and the answer is false. It should start pumping again between 90 and 100, in this case 100 psi, and it will cut off or stop pumping air into the system at 125 psi. That's considered a fully charged system. Having ABS, or an automatic braking system, having those types of brakes only on one axle still gives you more control over the vehicle during braking than a vehicle without ABS. Well, true or false? According to the manufacturers of those that have created that braking system, the answer would be true. To have partial ABS is better than not having any ABS at all. Step on and off the brake pedal to reduce the air tank pressure. The parking brake knob should pop out when the air pressure falls to the manufacturer's specification. This is how you check which of the following. A, this is how you check that the spring brakes will come on automatically. B, this is how you check that the slack adjusters are adjusted properly. This is how you can check that the supply pressure gauge is working. This is how you can check that the brake pedal is tuned properly, or none of these. Well, the best answer on this one would be A. Pumping the brake pedal down lowers the air tank pressure, and at a certain point, the parking brake knob, which is not set, will set, and the spring brakes will come on at that point automatically. The air compressor governor controls when the air compressor will pump air into the brake safety valves. True or false? It's false. When the air compressor pumps air into the storage tank is what the governor controls. So air compressor governor controls when the air compressor will pump air into the storage tanks, not into the safety valves. Safety valves are part of the system, but the air compressor governor will turn the air compressor on and off to pump air into the storage tanks. Air storage tanks are used to hold compressed air. True or false? Yes, that's what it's called. It is called compressed air because it's pressurized. Air brakes are really three different braking systems. You have a service brake, a parking brake, and an emergency brake. True or false? The answer is true. It can be argued that the parking brake and emergency brakes are one and the same, but technically and on your knowledge tests, they would be considered three different braking systems. Your service brake being the one with the pedal, and your parking brake being the knob that you pull out to set the brakes, and the emergency brakes being that thing that pops out in excuse me, in an emergency. The braking effect of the engine on a long, steep downgrade should only be a supplement to use of the brakes. True or false? Well, that's false. Just the opposite is true. The air brake should be a supplement to the braking effect of the engine. So you want the engine to slow you down more so than the brakes themselves. Doesn't mean you can't use the brakes. Definitely you need to use the brakes, but you wouldn't need to use the brakes as much or as often if your engine is helping to hold you back. So that is why you would shift to a lower gear before you start down a steep downgrade. Brakes can fade or fail from excessive heat caused by using them too much and not relying on the engine braking effect. That's an important statement, and that is oh so true. Brakes heat up as they're being used. You've got a heavy load that you need to control, and if you're using the brakes excessively to slow that heavy load, it creates heat, which can cause your brakes to fade or fail, and you've got to be real careful about that. The safety relief valve protects the air tanks and the rest of the system from building too much pressure. True or false? Well, that's why they're called safety relief valves. Absolutely. So that answer is definitely true. The service brake system applies and releases the brakes when you use the brake pedal during normal driving. Now we're talking about the foot pedal. The service brake is the foot pedal. Applies and releases the brakes when you use that pedal. True or false? That is absolutely true, just like you would in any other vehicle, whether it's a car, pickup. That service brake applies the brakes as you're going down the road. Spring brakes are powerful brakes that are held back by air pressure. If the air pressure is removed, the springs put on the brakes. Is this true or false? Well, the correct answer is true. In the brake chambers at the rear of the bus, there are some very powerful springs that are pushing forward to set the brakes. Air pressure holds the springs back so that they do not apply the brakes. However, when you pull out the parking brake, it releases the pressure against those heavy springs, allowing the springs to set the parking brake. When the parking brake is pushed in on the dash, then the air goes back and pushes the springs away from the push rod, pulling the push rod away from the slack adjuster, which releases the brakes. All air brake systems have an alcohol evaporator to put alcohol into the air system. Well, it's not the kind of alcohol you might think of first and foremost, but it is a type of liquid that tends to dry moisture out of the air, like rubbing alcohol. And so this would be false. All air brake systems do not have alcohol evaporator to put alcohol into the air systems. So that's the false part about that statement. Not all vehicles have alcohol evaporator. But for those that do, it does put alcohol, a drying agent, into the system to help keep water out of the air. The safety valve in an air tank is usually set to open and release air at 150 psi. So now we're talking about a safety feature. And the safety valve is something that opens up to release pressure should the air compressor not shut off and just keep pumping air. So the question again, a safety valve in an air tank is usually set to open and release air at 150 psi. And if you've never heard this before, you probably don't know that that's true, but it is set at 150 psi. A slack adjuster is a lever that connects the brake chamber push rod with the return spring. True or false? The answer to that is true. A slack adjuster is connected on the one end to the push rod, which goes into the brake chamber. And when the springs push the push rod out, it turns the slack adjuster, which in turn turns the camshaft and applies the brakes. So a slack adjuster is a lever that connects the brake chamber push rod with the return spring. What does an alcohol evaporator help prevent? It helps prevent water leaks, air in the system, dirt in the system, or air from leaking, or none of these. And those of us who already understand the system understand that it doesn't do any of those things. It helps to evaporate moisture in the air line to prevent it from freezing and affecting the operation of the brakes overall. Pressing and releasing the brake pedal unnecessarily can let air out faster than the compressor can replace it. Well, that's true. Yep, it's very true. So if you do it repeatedly and in quick succession, it could use more air than the air compressor can make up, which would sound your alarm for low air pressure, and eventually when it gets low enough, we'll automatically set the emergency brake. All trucks, tractors on tractor trailers, and buses must be equipped with emergency brakes and parking brakes if they have an air system. Absolutely true. Absolutely true. What can be done to help prevent oil and water from entering into the system or building up in the air tanks? Avoid using the brakes in humid weather. Perform an air brake pump down test 3 times a day. Keep light pressure on the brakes when driving through water. Use an alcohol evaporator. All of these or none of the above? Well, the correct answer is none of the above. None of these things can help. Bleed the tanks, the air tanks, frequently is the best way to get rid of excess moisture and to keep oil along with the water from building up in the air tanks. So they need to be bled out. Most systems have automatic bleeders, so your air tanks will bleed themselves to prevent any problem. Letting up on the brake pedal increases the air pressure and releases the brakes. True or false? And the answer to this one is false. A service brake chamber contains a flexible rubber disc called a diaphragm, a metal rod called the push rod, and the return spring. When you press the brake pedal, compressed air fills the service brake chamber, forcing the diaphragm to move and push out the push rod. As the push rod comes out, the brakes are applied. So when you let off the service brake pedal, air escapes from the brake chamber and releases the brakes. How often should you drain air tanks? Every hour, every 2 hours, 3 hours, 4 hours, or none of the above? And again, the answer is none of the above. Should bleed the tanks every day, at least once a day. And again, on newer vehicles, that's done automatically. You don't have to worry about it, but it might be a question on a test. Which factors will not cause brakes to fade or fail? Brakes can fade or fail from excessive heat caused by using them too much. Brakes that are out of alignment. Using the engine brake and not using the brakes often enough can cause them to fail. Mismatched retread tires on a trailer will cause your brakes to fail. A and B, C and D, D, or all the above. Actually, A will cause your brakes to fail. B, if they're out of alignment or adjustment extremely so, will cause your brakes to fail. Using the engine brake and not using the brakes will not cause your brakes to fail. So C would be a correct answer. Mismatched retread tires on a trailer has nothing to do with the operation of your brakes. So mismatched retread tires will not cause your brakes to fail. So the correct answer then is C and D. The maximum leakage rate for an air brake system should be less than 2 psi in 1 minute for single vehicles and less than 3 psi in 1 minute for combination of vehicles. So what this is saying is if you're just sitting there with the emergency or parking brake released and the engine is not running, and you're not pumping the brakes, you don't have any brakes on, you're just sitting there. The air brake system should be less than 2 psi. And if you've got a trailer hooked up with the air brake system tied in, then it should not be more than 3 psi in 1 minute. And that is correct. That's a true statement. So for our buses, since we don't have trailers, when you do your air brake test, at some point with the examiner, and again we'll go over this, or you will go over it when you do your N-bus with another instructor or myself. This will be the very first step. Once we've got everything set up and ready to go through our test, you will be looking to see if you're losing more than 2 pounds per square inch in 1 minute, and you'll tell that by looking at your gauge. Wait for normal air pressure. Release the parking brake. Move the vehicle forward slowly, and then apply the brake, service brake, firmly using the brake pedal. Best describes testing the parking brake. True or false? Of course, this is false. You're not testing the parking brake at that time. You're only using the foot pedal, and so you are testing the service brake. A supply pressure gauge indicates how much pressure is in the air lines. The pressure gauge does not tell you how much pressure is in the airlines, because in the airlines, the air pressure comes and goes. And what's important is what is in the air tanks, the compressed air in your contained system. Holding tanks, some people call them. But it has nothing to do really with your airlines, but rather your air tanks. Only a certified mechanic can check slack adjusters. No, anybody who is taught or trained can check slack adjusters. One of the things you need to know is that a slack adjuster, when pulled on, cannot move more than 3/4 to an inch in play, must never go past the 90-degree point when the brakes are fully applied, and you can check all of that if you care to. It's not required of you as a bus driver, but certainly you would need to know what needs to be done if your brakes don't feel right or you think there's some kind of problem going on. You could suggest maybe the slack adjusters need adjustment. The air compressor pumps air into the storage tanks, containment tanks, holding tanks, whatever kind of tank you want to call them. Is that true or false? Well, that's what the air compressor does. The governor tells it to kick on. It pumps air into the storage tanks until it reaches a certain PSI, and then the governor tells it to shut off. And so that's what the compressor does, into the storage tanks. And our last question, rather a detailed question, which is the correct and complete air brake testing procedure? A, you should chock the wheels Start with a fully charged system of 125 psi. Now there's a point that you need to take note of. 125 psi is a fully charged system. Release parking brake. Turn ignition on without starting the engine. Observing less than 2 psi air loss per minute. Applying service brake. Observing less than 3 psi air loss per minute. B. Pumping the service brake down to 60 psi and observing the light and alarm, audio alarm, that you're getting low air pressure. Pumping the service brake down further to 20 to, it says 25 psi here, but it should be 40. Observing the setting of the parking brake, starting the engine, and building air pressure to 60 psi and observing the stoppage of alarms. C. Timing the air pressure between 85 to 100 psi to be less than 45 seconds. Listening for air release signifying fully charged system at 125 psi. Increasing engine RPMs to assure the parking brake holds. Applying service brake, releasing the parking brake, drifting ahead, applying the service brake, observing left, right pulling, observing stoppage, setting parking brake. All of these, or just A and C? Well, to save a little bit of time, the correct answer is all of these. That is actually the way you do an air brake test. And again, I have cheat sheets for you, and we will go over this in a bus, probably tomorrow afternoon. When you go to take your knowledge test, you need to understand that this is all part of your air brake test procedure. And then when you go for your actual skills test, either to a third party or with PennDOT, they will ask you to do your air brake test, here it is, before you pull out onto the highway. If you fail any part of this, you will fail the exam and you will not continue with the exam. You'll have to reschedule and come back to take the test a second time. But again, don't worry about all these details at this point. They'll be reiterated over and over again long before you have to go out and actually take your skills test. All right, so that completes air brake instruction, at least for this point in our training time. And I hope that you have found it helpful.